Hello and what's up everyone, welcome to the fourth video in our 7 days of computer vision projects, where we will be covering simple computer vision projects using image processing and open source tools. I am Viper from DataQuell, and today we are going to write a code which will play the popular Trex game in Chrome browser, but without using any gestures, and we will be using only image processing. Without getting any delay, let's get right into the topic. Just like previous times, we will start by imports, and first thing to import is PyAutoGUI. We will install it in a while, then NumPy, Kinter, OpenCV, Matplotlib, and keyboard. If you do not have installed PyAutoGUI or keyboard, then please do something like exclamatory sign, then pip install PyAutoGUI space and then keyboard. The exclamatory sign allows us to use commands from notebook. Let me run this and wait for the result. As you can see here, it is showing me that my requirements are already satisfied. If you are following my previous videos, then I mostly start with dummy show function, which will take image and then figure size. Then I will make a figure of given size and then show the image. Let's test this function by passing a dummy image of 100 by 100. Now make an object of Kinter as root and take the width of the screen and height of the screen using it. Then put these height and width in tuple. By printing it, it shows me that my height of the screen is 768 rows and then width is 1366 columns. Of course, both are in the pixel format. Next, we need a screenshot of Trex game window. So in order to get that, let's go to the Chrome browser and then type Chrome : // and then Dino. Once opened, hit space and then take the screenshot as fast as possible. I am on Windows, hence I hit print screen key and then insert key at the same time for the snapshot. Once taken, go to paint and then paste it by Ctrl+V. Then save this image as PNG image in the local directory. I have already done this, so let me show this. The reason we need the screenshot is that we will be extracting dinosaurs or dino and then the place where dino lies and the region where the object appears. In further steps, we will take background subtraction with this screenshot portion or some ROIs. Let me show my screenshot image in markdown block. This is what my screenshot looks like. There are a few things we will do with this image. First is to take a part where dinosaurs lies. Second is the portion right to the dino's place where objects comes and dino has to jump. And final portion is where objects appears and then dino had to dock. Let me read this image as game window in grayscale format, then show it. Let's define variables for ROI or region of interest. We will call bottom region of interest or BROI for the portion where object appears and then dino had to jump. And TROI is the place where object appears and dino had to dock. It is of course region of interest in the top. So BRR1 means bottom ROI's first row and BRR2 means bottom ROI's last row, and same for columns. The values of each BR or TR is respective of the screenshot of game window, and please don't forget to look at the graph above. Let's first take ROI for top, TROI from game window, and similarly take bottom ROI too. In my case, the dino will be in the place between rows 370 to 500 and columns 50 to 180. So let's crop it. Then show the dino image. Once we have done up to this, let's go to the part where we will take the screenshot and other stuffs. First, we will define a resolution of screen size and make a new OpenCV window named as live, where we will show our screenshot. Then we will resize it by 480 by 270. Then define frame count as FC and then give it default value to 0. And then define another variable increase underscore every as 7. This variable will be used to increase the width of ROIs. Now start the main while loop using PyAutoGUI.screenshot. Take a screenshot and make it a NumPy array. Let's first see the screenshot by using cv2.imso. Then window name will be live that we have already stated, and then the frame. Also add a key event and wait every 1 millisecond. If escape key is hit, then break out of the loop. And finally, add code to destroy all windows. Let's run it and see whether we can see our screenshot or not. As you can see here, we can see the screenshot, but OpenCV shows in BGR format and our frame is in RGB format. So the color seems to be a little bit different than the original. But we don't need to worry about color spaces in this project, so I am going to ignore it. Next, we will make grayscale image using the frame. We will use cv2.convertColor, which is CBT color, and passing the frame and color space flag. Then we will take frame ROI from the grayscale frame. Just like previous ROIs, we will use the TR and BR values. Then we will take BROI from game window again. Now we will do template matching. We will use our dino image as template and current frame as the image. So we will pass gray frame and then the template image and a norm coefficient. And also we will use a threshold, and let's take shape of dino 2. Next we will use where the dino has been matched. We will use numpy's where method with our threshold value. Next comes our tricky part. How do we conclude that dino has been found? If we are not in dino page, then the LOC will be empty, and if we are on dino page and we found a dino, then it will contain locations. Let's write a code to check if LOC is empty. Print LOC to confirm. Currently, our current screenshot does not contain dino. Thus, our array is empty. Let's get into the dino page and come back to our notebook. As you can see here, our array is not empty now. It contains the locations of template. The conclusion is that if there is dino matching found, then our LOC will not be empty. Now let's check where is the maximum value of dino location. If absolute difference of LOC 0's max value with 370 is below 20, then we will work further, which means that dino possibly is on the ground. As you can see in the result, all values are around 370, but the values will depend on the screenshot image. So our purpose is that we will only check if we need to jump or not, only if dino is in the ground. Now we will perform an absolute difference between frame ROI and bottom ROI. Bottom ROI is the ROI from the screenshot image where object appears and we have to jump. And frame ROI is the same place from current frame. We will need to convert both ROIs to float 32 and then convert the result to unsigned integer of 8 bits. Then we will apply strict thresholding, that any value between 50 will be 0 and above or equal to it will be 255. Now we will be checking in difference that how many pixels are white, and last time I checked 100 was best value for me. This is little bit tricky that by subtracting BROI and frame ROI we will be cancelling out more similar values, or more similar values will be black and more dissimilar values will be white. We have applied strict thresholding and thus we made sure that those parts will be white where the objects appear. Then we assume that we need to jump as the cactus is near. Thus keyboard.press and release space key is done, and increase the frame count and also show the difference. Let's run the code. As you can see here, the difference window is not shown currently because the dinosaurs is not found. But once I go to the dino window, I will be able to see it. Currently, the dino is jumping automatically and I am not doing anything here. The dino does not run that far, and it seems that we need to do some values tuning in order to make it little bit fine. Currently, ROI does not change automatically, and to do that, we will see if frame count is equals to increase every. And if it is, we will make frame count 0 again and increase the right value of column and then print it. Then we need to clip the value. If value reaches above the maximum column numbers, then make the value maximum column numbers. This operation is equivalent to the np.clip, and then we will again crop the game window to get new BROI. Not only BROI, but frame ROI also has to be changed. Once it is done, copy this code and then paste it just below frame taking part, because sometimes we will change column values back to default. If Trex window is not found, then we will make the cropping values back to default. Let's run this code and see what happens next. Our dino is not able to jump properly. Let me fix my main problem. My main problem seems the screenshot image. As you can see here, there is a cactus in the middle, but to take background subtraction, we need to have as plain as possible. Thus, I again have to go to the Chrome and take a latest screenshot and then save it on drive as chromedino1.png. Now changing the image name and running it all again. The problem seems to be on the time when to hit the space. we need to write some code to confirm that when could the cactus hit the dino, and then we need to jump just some moments before that. We could extract the speed of the cactus too. But for now, I am going to end this project. I hope you have learned something valuable here in this video, and we will be grateful to get any feedbacks. So please let us know if anything pops up. Please stay tuned, and I will see you in the next video where I will be making a system where we could write something in canvas by moving fingers in front of the camera. I hope you are as excited as I am, because this project is going to be most cool project we have ever introduced in this channel.